All right, so let's talk about vectors. Vectors are a very useful concept in physics and engineering. And vectors have just two characteristics. And these two characteristics are its length, which you can also call the magnitude, and the vector's direction. So if you know the length and the direction of a vector, you know everything there is to know about it. All right, for example, here are two vectors, and in fact this is the same vector because they have the same length and they point in the same direction. So the same length, they both point the same direction, kind of to the northeast, we'll say. So these two vectors are the same, they're equivalent. Doesn't matter that they're not drawn in the same spot, you can draw them anywhere. But if I pick this vector up and set it right on top of this one, it would be exactly the same thing. So these two vectors are the same, so it's just the same vector. These two vectors are not the same. Although they point in the same direction, obviously this one is longer than this one, so those two vectors are not the same. These two vectors have the same length, but they point in different directions, so they are not the same. These two vectors have the same length, and they kind of lie in the same direction, but they actually point different ways. This one points up to the northeast, we shall say. This one points down toward the southwest, maybe. So it's very important where you start the vector and which direction it points. So these two are not the same. Those are different vectors. All right, so we can draw vectors on the Cartesian plane, on the XY coordinate plane. So I have a vector here with a certain length, and it points in a certain direction. So if I know the initial point, and I know the terminal point, the one where it points to, then I know everything there is to know about this vector. If I know these 2 points, then I know how long it is, and I know which direction it points in. So I could take this vector, and I can move it maybe over here, and as long as I kept it the same length and in the same direction, it would be the same vector, so I could draw it anywhere. What we want to do, though, is we want to put this thing in what we call standard position. Standard position is going to be when I put the initial point at the origin. So I'm going to move this initial point right here to the origin. Okay, so if I do that, where will the terminal point then be? So I have to keep the same length and it's got to point in the same direction. So if I move this initial point down 5 and over 1, where would the terminal point end? Well, I would have to do the same thing to it, so I would have to move the terminal point down 5. So if the y-coordinate starts at 3 and I go down 5, I would be at -2. And I have to move it 1 to the left, so I would be at 3, -2. Be right here. So now it's the same length and points in the same direction. Okay, so how did I figure out this point 3, 2? Well, I looked at it, just counted in that case. But more systematically, I knew my y-coordinate, the y-coordinate of my initial point was at 5. So I knew I had to move it, that should be -2. Lost my mind, 3 to -2. Right, so my initial point was at 5, where the y-coordinate was at 5, and the terminal point was at 3. So I know if I'm going to move this down 5, then I need to subtract 5 from the y-coordinate. So I need to do 3 minus 5 to get the -2. And to get the x-coordinate, I would do, of course, 4 minus 1. So to put a vector in standard position, all you need to do is subtract the y-coordinate of the initial point from the y-coordinate of the terminal point. Subtract the x-coordinate of the initial point from the x-coordinate of the terminal point. So it's really just common sense. All right, so any vector, anywhere we draw it, I can move it into standard position with the initial point at the origin. All right, when you do that, we're going to write this vector this way. So we're going to use these little symbols. People use all kinds of different symbols. Sometimes they just use parentheses. We'll use the little Pac-Man symbol there. So our vector is 3, -2. This vector, we're going to call it V for vector. and we're going to put a little line over it. That means vector. So this would also be vector v, because it's the same exact one. So we could say vector v is equal to this. So with only these two numbers, we know exactly what the vector is because it's in standard position here. All right, what about the magnitude of vector v? All right, magnitude, of course, just means length. And we're going to symbolize it with the little absolute value bars. So if you see absolute value bars around a vector, it means the length of the vector or the magnitude. Well, that's really easy to figure out how long this is. I just have a little triangle, little right triangle. This side is 2 units long. This side is 3 units long, and you would just use the Pythagorean theorem. So you would get 3 squared plus 2 squared is equal to the magnitude of vector v squared. So you would have 9 plus 4 is equal to that. 9 plus 4 is 13. So the magnitude of vector v is equal to the square root of 13. So really simple. So notice all I did to do this was I just squared the x-coordinate, squared the y-coordinate, -2 squared is also 4, just like over there, and took the square root. Okay, so in this case, we would have the square root of 3 squared plus -2 squared. So that would be the square root of 9 plus 4 and the square root of 13. So it's really, really easy to find the magnitude of a vector. All right, so here we have vector v, which is 3, -2. Let's graph vector u, which is 4, 8. So 1, 2, 3, 4. And go up here to 8. So there's vector. Oops, I missed my dot. Cheat a little bit. There's my vector 4, 8. This is u. All right, we want to add vectors together. So it would be really important in physics and engineering and different kinds of sciences to add vectors and also subtract vectors. So here we'll do an addition. All right, so what does it mean to add 2 vectors together? So what I want to do, or how we're going to define it, if I'm going to do v plus u, I'm going to do vector v, and then I'm going to attach vector u to the end of this one, and then see where our final result ends up. So here's vector v, down here at 3, -2. So remember, I can draw vectors anywhere on the board I want as long as I keep them pointing in the same direction and they have the same length. So I'm going to pick this vector up and I'm going to move it right here. Okay, so I'm going to put the initial point at the terminal point. I'm going to put the initial point of u at the terminal point of v. All right, so if I pick this up and I set it right here, where will my terminal point be then? So to do that, I'm going to have to move this vector u down -2. So the y-coordinate would then be at 6. And I'm going to have to move the u vector over 3. So the x-coordinate would be at 7. 2, 3, 4, 5, 6, 7. So the y-coordinate would be at 7. Or the x-coordinate would be at 7, the y-coordinate would be at 6. Here, and it would look something like, I missed again, cheat a little bit. It would look like that. So here's vector u now. I just picked it up and moved it down there. Okay, so again, how did I figure out this point was at 7, 6? Well, I just picked it up and moved it down here, so I know that to do that I have to move it down 2 or minus 2. So I did 8 minus 2 and got the 6. I had to move it to the right 3. So I did 4 plus 3 and got 7. All right, notice now that if I pick up vector v, it will be this one. So I have this parallelogram here. All right, but what is v plus u? Okay, so v plus u will just be the vector v followed by the vector u. So v plus u will be this vector. That's v plus u. Okay. So think about it as being you're a bug walking along these vectors. I do vector v, I follow along vector v, then I follow along vector u. Where do I end up at? I end up at 7, 6. So v plus u is 7, 6. All right, so this is a pictorial representation of what's going on. But think about how easy this really was to figure out v plus u. To get the x-coordinate, I did 3 plus 4. To get the y-coordinate, I did negative 2 plus 8, got the 6. So it's really easy to add two vectors together. If they're in standard position, you just add the x-coordinates, add the y-coordinates, and you got it. Subtraction works exactly the same way. If I do v minus u, so v minus u would be 3 minus 4. That would be negative 1. Negative 2 minus 8. And that would be negative 10. So it's also really easy to subtract vectors. So here I'm going to multiply v by negative 1. Negative 1 is a scalar, so still I'm just multiplying by a scalar. So all I have to do is multiply each coordinate by negative 1. So 2 times negative 1 is negative 2. 3 times negative 1 is negative 3. So I get the vector negative 2, negative 3. Oh, I get this one. So notice what multiplying by a negative did. Didn't change the length. They still have the same magnitude, but they point in exactly the opposite direction. And if I wanted, I could pick the blue one up and set it right up here, and it would look like this. It would be sitting right on top of it, just be pointing in the opposite way. So multiplying by a negative just changes exactly the way that it points, that the vector points. Doesn't change its magnitude. All right, so we've added, subtracted vectors. We found the magnitude of vectors. We've graphed vectors. How about multiplying two vectors together? All right. So there are at least two ways of multiplying vectors together. We have the cross product. That's one way of multiplying them. And we have what's called the dot product, or some people call it the scalar product. So there's two different ways of multiplying vectors. We're going to talk about the dot product. The dot product is really simple. So let's say that I have these two vectors. Let's say that vector A is 3, negative 7, and vector B is negative 5, negative 4. So I want to multiply these two vectors together, and I'm going to use the dot product. So I have A dotted with B. So A dot B. All right. It's really simple. All I'm going to do is multiply the two x-coordinates together. So I'm going to do 3 times negative 5 plus the two y-coordinates multiplied together. Negative 7 times negative 4. When I do that, I get negative 15 plus 28. And 28 minus 15 is 13. I get 13. Notice that this is just a number. My answer is a number. It's not a vector. So it's just a plain number or a scalar. That's why some people call this the scalar product. So when you multiply two vectors together using the dot product, You don't get another vector, you just get a plain number or a scalar. And it's really easy to do. Just multiply the two x coordinates, multiply the two y coordinates, and add those two numbers together. Okay. The cross product is something a little bit different, but we're not going to talk about that. All you'll need to know here is the dot product for multiplying two vectors.